Okay, we are looking at objective 42 today in your money textbook. So again, if you don't have your money textbook, go grab that, hit pause, go grab it. It's going to be on page 79. The name of the objective, compare investment or saving strategies. So this is, it can seem like it's a really hard one because there's a lot going on. All the math in it is stuff you have done in objectives before this, and it's just kind of putting it together. So the biggest part about it is kind of reading, following along, figuring out what you need to do. So I think this video can be very helpful when you're doing practices and the tests to kind of figure out what you should be doing and making sure you have a plan of what you want to do. And a lot of times it's going to involve just kind of taking one thing at a time. So let's read through number 31 here. Said when Klaus was born 10 years ago, his grandparents opened up an investment account for him. When his sister Inga was born 5 years later, their grandparents opened another investment account for her. The grandparents made no additional deposits after the initial deposits, so meaning the money they put in right away, that was it. They didn't add any more. But the accounts continued to earn interest compounded annually. Okay, so that's going to be important. One, that it's compounded, and second, that it was once a year, not more than that. Here's the information. Okay, they put in more money for Inga and for less time, same interest rates, more time for Klaus. So because she was born later and done it for 5 years, they're ended up going to get their money out at the same time. It says whose account has a greater final balance now, and how much greater is it? So now is, like I said, they both would end right now because the one was 10 years ago, the other was 5 years later, and it lasted for 5 years. So they're both ending now. Okay, so they're both compounded annually, so we're going to use this formula for both. Okay, and we just take one thing at a time and then figure out our answer. Okay, so the first thing, let's look at Klaus. Now remember, in this formula, P is principal, 1 is part of the formula, R is your interest rate as a decimal, N is the number of years. Okay, so again, our setup, there's the principal, 1 is part of it, 4.4%, which is from the table here. Both their interest rates are the same. So that's 0.044 for 10 years. Order operations says you add these two. Okay, and that comes here. Now we need the exponent first. So that's going to be a button on your calculator that either looks like that, and you would hit 1.044, hit this button, then hit 10, or some calculators have this button, meaning you would hit 1.044, hit this button, hit 10. Let me actually type that in. I didn't write that out. That would be 1.538, so on, and then times that times 2,500, and you should get something around an answer to $3,845.43. Okay. Maybe I can, just so you can see. So again, when I type that in, just in case you're following along here, it should be 1.538, and then a bunch of numbers. Okay, and then you multiply, and you get that up here. Okay, same formula for the next part. A bigger investment. Okay, the setup here is the same, 1 and 0.044. Years is 5. So we add this together, we get this here. We're going to order operations after that is do the exponent before the multiplication. So again, I'm going to put 1.044 and do it to the fifth. So I'm going to leave this 3200. When I did that exponent, I get 1.240 and then a bunch of numbers. When I multiply that, you get this 3,968.74. So you can see Inga's ended up being more. And then the question was how much more? So we subtract the two numbers, which I did right here, and hers is $123.31 more. Okay. If we go to the next problem, number 32 here. I don't think I'm going to go through this one. I'll just talk about it quick because it's basically the same as the last one. The only difference is that the percentage for each is different. So, and the time is going to be the same. So again, there's two people. The first person has $5,000 principal at 2.5% compounded annually. Okay. The second person is $2,500 at 5% compounded annually, and they're both going to be for 30 years. Okay, so again, I didn't read the whole problem. It's very similar to the last one, but the key is that they're both compounded annually, so we're using the same formula we did in the last problem. Principles will be different, percentages will be different, but the way you go through the problem will be the exact same. Add, do the exponent, multiply by 5,000. Add these 1.05 to the 30th, get a number, times 2,500, and you get another number here. So the second person is going to be bigger. Again, it asks how much bigger, so you subtract, and you get Linnell is $317.02 more. So again, I didn't go through that step by step like the last one, but it's a very similar problem. Okay. All right, so now let's go to the next one. This one looks like there is a ton going on. So we just have to take our time, okay, and figure this out. Okay, so it says Mr. Montgomery bought a 5-year certificate of deposit, so that's a type of investment, in the amount of $6,000. So it means he invested $6,000. The CD earned 3.1% interest per year, compounded quarterly, okay, which is going to be a big thing we need to know, and they do give us the formula down here for compounded quarterly. Okay, his neighbor, Mr. Allen, made the same investment, but he cashed his CD after 2 years and paid an early withdrawal penalty of $49.08. So he didn't let it go the full 5 years, and he had to pay a penalty, okay, to take it out early. He immediately used the remaining money to buy a 3-year CD that earned 3.2 interest per year compounded quarterly, so also compounded quarterly. It says whose account had the greater final balance after 5 years and how much greater was it. So a lot going on here. So let's do one thing at a time. Let's first look at just Mr. Montgomery. So his is the more quicker one to do because he just did one thing. He bought this CD, $6,000, okay, compounded quarterly. So make sure we look at this. Print P or B, capital B is the balance, P is the principal, so $6,000. 1 is part of the formula. R, interest rate, 3.1 for this, so we move that twice, we have 0.031. 4, which is because it's quarterly and it's done 4 times per year. Okay, and the N, this is important, very important, is not years in this formula, it's the number of quarters. Okay, so quarters mean 4 times per year, and this happens for 5 years, so the number of quarters eventually becomes to be 20. Okay. Now when I did this work for this problem, I was in school, and we had the nicer calculators where you can just type in everything. But again, if you didn't have that, we could still figure this out. I might not write out everything, and I might only do it for this one part instead of the other one. So I would take the 0.031 divided by 4, gives me 0.00775, and then I'll do 2 steps here together. I'll add that 1. So in there I would get that's bad 7. I would have this, and then to the 20. Okay, so I would take that number to the 20th, and again, it's not even be that much bigger. It would be 6,000 is out here. When I've taken that number just barely over 1 to the 20th, I get 1. Let me move that out. 1.166, bunch of numbers after that. Now when I multiply it, I would get this up here, the $7,001.76. Okay, so that's where Mr. Montgomery is. And Mr. Allen, now here's a lot going on here, so we gotta take our time. We started out the same way. Okay, it's compounded quarterly, $6,000. The 1 is part of the formula. Interest rate's the same. The 4 is part of the formula. Number of quarters, it's 4 times per year, but he took it out after 2 years. So N is going to be 8. Now, I won't go through, this inside would be the same as up here. It would be 1.0075 because the inside is the exact same. Set it to the 20th, I would go to the 8th, then times 6,000, and I would get this number. Okay, so after 2 years, that's what his balance would be. Now there was a penalty, okay, $49.08, so I got to subtract that. So this is what he actually has after the 2 years, after the penalty of $49.08. Then it says he put that money into another CD, and that got just barely more interest rate, and it was a 3-year CD. So this overall it'll be 5 years, but so now let's see if he made a good decision. Okay, so he took it out, had to pay that penalty. Now we put these numbers in the exact same formula. Okay, the principal's here, 1's part of it, the 4 is part of it. Now we have 0.032. The N is number of quarters, so 4 quarters per year times 3 years, so the N is 12. Okay, now inside the parentheses we have 0.032 divided by 4, so it's going to be just a little bit bigger as far as the number in there. So we'd have this out here. When I took the 0.032 divided by 4, that's 0.008. Add the 1. So we'd have this. So inside the parentheses, just a little bit bigger than up there. Take it to the 12th, then multiply, and you'll get this amount here. Okay. So Mr. Montgomery ended up with this. Mr. Allen ended up with this. So Montgomery was bigger. We subtract them, $33.13 bigger. So that one is very involved, a lot going on. Do the best you can following it, and see what happens. Okay, take it one step at a time. Okay. Next one looks like there's a lot going on, but it's actually quite a bit easier problem than the last one. Okay, it says Mr. Dulaby is considering which of the 2 investments to make. He could buy a United States savings bond that is guaranteed to double in value in 20 years. Okay, or he could buy a tax-free municipal bond that earns simple interest. Okay, so it's been a while since we talked about simple interest. It says the gain on the United States savings bond is subject to federal taxes. The table shows how much would be invested in each bond and the taxes that would be have to pay on the savings bond. Okay, so here's the information of everything. It says which bond will earn more over 20 years and how much more will it earn. So the first one, take these one step at a time. Savings bond. It says it's going to double in 22 years. Okay, so he puts in 11,000. It's going to end up doubling in 20 years. So it's now going to be 22,000. And this is the only math you have to do is that there's going to be a tax. So we went 22,000 minus the tax. I just didn't write this in here. This would be what the answer I wrote over there, $20,130. Okay. The next one is the other plan is putting it into a simple interest plan, and they give us this this formula here. Okay, balance equals principal times 1 plus NR, where R is the interest rate, N is the number of years. This is actually the same as the formula we've looked at in the past, where we use the simple interest as PRT and then add it to the principal. So right here, so if we said capital B would equal that, that's the exact same thing as we're doing here. So if we use this formula, we take 11,000 as the principal, 1 is part of it, part of the formula, 20 years is N, 0.05 is the interest rate. Okay, order operations, so you multiply this first, this times this is how we get this 1. Then we take 1 plus 1 is 2, multiply, and that comes out to be 22,000. This would be the same thing if we did it this way, if we did 11,000 plus 11,000 times R is 0.05 and T is 20 years. Because this times this is 1 times 11,000 plus 11,000 would equal 22,000. So here, because there's no taxes on it, that would be 22,000. So the question was which one is better and by how much more? Okay, it's basically just it's the amount of what the tax was. So the tax-free municipal is better and by 1,870 more. Okay, so again, that one looks like it's super complicated because it's so big of a problem, but it's actually one of the easier ones in this objective. So, looks like we got one more problem. Okay, number 35 says Mr. Betancourt sold 2 stocks that he bought 10 years ago. He spent $2,000 on each, so his principal is going to be $2,000 on each. One stock was a dividend-paying stock, which means stockholders get a small share of the company's profits. So that means they give you a little check here and there of that you've earned just by being a part of this stock. Over 10 years, his total earnings from his stock's dividends were $1,024.66. And the stock's value increased at an average rate of 4.9% compounded annually. So again, we're going to be looking at compounded annually. The other stock did not pay dividends, so there's no extra money coming in, but its value increased at an average rate equivalent to 8.1%, so a much higher interest rate. Again, compounded annually. It said, what stock do you make more profit from and how much more? Okay, so the first one, we're going to use this formula, which we've used before, compounded annually. $2,000 is the principal. Interest rate was 4.9. Okay, we're going to add that to 1. So 1.09, we're going to take that to the 10th power, times by 2,000. You should get this number. Okay, so I went through that kind of quick because we've done it up above. If you're not getting that, send me a message. I can go through that step by step with you. Okay. Now that's how much the stock itself earned, but he also had those dividends of $1,024.66. So we had to add that. This would be the total he earned from that first stock. The one that did not pay dividends, we just have to do the formula. So we have 2,000. It's all the same as up here, except the interest is 0.081. So we add the 1, so we have 1.081, take it to the 10th, times it by 2,000. Okay. You're actually going to get something that looks like this, but we need to round it. So we round to this number, look at the number next. Because that's a 7, this has to bump up. But because this is 99 cents already, if you add a penny to round up 99 cents, you have to round up the whole thing to the next dollar. So we get $4,358. So this one ended up being a little bit more. And how much more? So we're going to subtract. Okay. And it's going to be $106.44 more. So the stock that did not pay dividends, the second one, you got that much more. Okay, and so that is the last problem of objective 42. A lot going on in that one. Do the best you can. Follow along in this video. Do a couple practice problems, which, again, in the money workbook. Start right here, objective 42. Again, there's a lot of problems there. You don't need to do all of those. Pick some out. One of each kind from what we looked at in the money textbook here. Answers are right here. See how you're doing. If you're not getting it, let me know. Help me out. If you're getting it, send me a message. Say you're ready for test 42 or 41, 42. Alrighty.